Okay, let's talk about web development. Where it all started, the internet. It was a Defense Department research that was tasked with surviving World War III, having won World War II. We looked at why is it that Germany was defeated. One of the facts is that we just bombed the heck out of them, so that they could not communicate. They communicate effectively and sustain a defense against our troops. And says, well, how can we do so that this doesn't happen to us? So there we have the interstate highway system for being able to escape cities with all the jam of possibly escaping the city, and the internet, right, of being able to have a very redundant system that has no central point of failure, that should be able to maintain communication regardless of where you bomb it. After the Defense Department not unwillingly, making available to the public for for-profit use, or by research institutions or universities and folks to see how could they convert that into some entrepreneurship ventures. It just exploded in the 90s. Once it was made available to the public. The web is a functionality of the internet, of just being able to easily connect related documents with one another, where these documents are spread over a wide area network, and as long as you know the name of the machine and the directory and the name of the file, you can create links or hyperlinks that easily navigate from one content piece to another content piece, right? Which we call web pages. Tim Berners-Lee in the 90s, he revolutionized this idea by mostly for research purposes and sharing research data with his colleagues. But then quickly just caught on, and it was just ubiquitous everywhere in all research institutions, major universities, and folks, obviously with entrepreneurship ideals, they were able to make a huge economic success. Some milestones: the internet in the 1960s, a particular model on how is it that the different types of machines would talk to one another. One of the main ways that still is in vogue today is the client-server architecture, where you have a kind of a centralized machine that we call the server that provides resources such as, used to be just file systems that usually designed to have heavy traffic, presumably from smaller machines that are asking for these resources. And the server would respond to these requests, this request-response model of interacting between these two machines. In the 80s, revolutionized of reducing all these huge machines, room-sized machines, to something personal that somebody can put on your desktop and take home. The World Wide Web in the 1990s, and the dot-com boom in the 2000s, and the busts shortly after that, where folks were saying, how we can, there's a lot of potential. So a lot of different things were experimented in the late 90s, early 2000s, only to discover that there was not much value there. A lot of good ideas, but no substantial economic value. A lot of the ideas that were invented in the late 90s lived on still today, just like client server are still with us. Ideas, and a lot of the ideas that were invented then are still with us, such as web services are still with us, right? XML, JSON, all these ideas which failed in the 90s have a big success today. Now that we know how to make money out of it. Then the 2000s, the final realization that the web was a development framework, that we actually build applications, dynamic applications, on top of this new framework, and we could apply the same engineering engineering practices that we can apply on desktop application. We can apply also on web application, building applications on the run on the web. On the 2010s, the mobile computing, big data, the miniaturization, having supercomputers in our pockets and having access to the entire content ever written by human beings at our fingertips. Where are the 2020s? I don't know. Where are we going? Maybe something on Mars, if Elon Musk has his way. A couple of other noteworthy dates on this, some of the evolutions of server frameworks. Folks, when we're building these client-server types of infrastructure, there was a lot of really great frameworks that were designed to run on the server. The idea would be that we would have a central place, right, with lots and lots of computing power, and that could serve lots of services for lots of distributed machines out there, the small personal computers that were out there. First, we looked at the common gateway interface, where you would be able to access a server and map a particular URL to an executable on the back end, right? And the back end could then access to local databases, have network access, unlimited network access, access to a file system, and be able to execute remotely things on the server, but invoked from a client. So that was a major step forward. An extension to that idea, we have a PHP that allows us to easily embed executable code, intermingle with HTML or any other dynamic content that will allow us to explore the first ways of generating dynamic content, dynamic HTML with embedded executable code in there. Further evolutions of the same idea, .NET and Java 2 Enterprise Edition, explore the ideas of creating, providing services for enterprise applications, large applications, and these are the first ideas of coming up with design patterns, of architectural design patterns such as model view controller, and singletons and factories, and a lot of those ideas that were invented for the server, for server frameworks, eventually made their way back into the client side, right? And today, frameworks such as Angular and React and Ember, all these client side frameworks are copying ideas that are a decade old, right, or 2 decades. Right, that have had a long time to mature on the server, and are now are very well understood and are readily usable in other frameworks, such as Angular or Ember or these Meteor. These are other frameworks that are client-side frameworks that are copying ideas that have been around for quite a while, that evolved on the server side. And Ruby on Rails, being able to very easily create data-driven applications that point to a database and provide you easily, user interfaces that allow you to very easily create records, update records, and data-driven applications. Node.js, the first realization that JavaScript is a coming of age, right? It used to be something that was used for animating kittens or having some really quirky things on the front end. Eventually becoming evolving enough of importance that can now not only be for the client side, but are now also a server side framework. So Node.js being able to run JavaScript on the server, Flask for Python. So these are the evolution on server frameworks. In tandem, we also had evolution on the client side. We had JavaScript, obviously. Netscape came up with a way to dynamically modify the documents, right, that were being parsed by browsers. Right? Browsers would download an HTML document, render it on the browsers, and we wanted to be able to dynamically update the DOM, right? Maybe by being able to animate things, move things around, or flash things, or give somebody feedback on something wrong with an input field, right? do some validation on the browser, and certainly many other attempts at making the browser dynamic. Certainly Adobe Flash was very successful at providing an alternative way of dynamically rendering something on the client side, of embedding this action script, a new language, right, to describe dynamic content, Dojo, jQuery. So there's a lot of evolution, all based on JavaScript libraries that were trying to address a lot of the complexities of building things on the client. One of the complexities was that everybody, the browser wars, right? So that made it very difficult to build on for the client, right? Microsoft had its own version of the browser. Apple had its own version. Netscape had its version. So everybody was kind of pulling their own way of trying to dominate the desktop, right? No longer was applications. Now the distinction was in who would dominate the web. So jQuery tried to address that, right? That there was a browser fragmentation. The JavaScript language was not fully supported across all browsers, right? And it made it so much more complex to build anything for running on the browser. Very much like what Android is happening today, right? Android, you have all these versions of Androids everywhere, and so trying to develop for Android is so hard because you don't know. You have to kind of design for the minimum common denominator, right? Of versions of Android that are very old, and you can't use some of the newer features of Android. So same thing was happening in the browsers, right? You had really old browsers, and JavaScript was not fully supported. So jQuery tried to solve that by creating a virtual API that you would code to this. Same with what Java tried to do, right? Java tried to do this, address this for the operating system, right? Instead of having to build separately for Windows or Mac or whatnot or Unix, you could have a virtual language, right? A virtual machine that you can. So same thing. jQuery tried to do the same thing for the browser. Other ways of things that come up is that we see more and more focus on implementing things on the client, knockout, being able to do data modeling on the client. Right, this was new. You typically did data modeling on the server, right? We have classes and map to databases and whatnot on the server. It was a novel idea that you had objects on the client side, right? That was Angular. Took this even further and says, well, you have all these disparate ideas hanging around. Well, let's bring all the ideas that became very popular on the server. Let's make an entire framework out of that, right? And provide that framework now on the client. We have components, technology, services, factories. All these are design patterns that became popular on the server side. And Google said, it would be great to re-implement or borrow a lot of the ideas that are server-side and now make them available on the client, because client-side development was becoming more and more complex, right? And we had to create abstractions that allowed us to deal with these complexities individually. Backbone, Ember, and finally where we are today, React. React is a little bit perhaps I would say maybe a little bit step backwards in the saying that we don't really need all those complexities that Angular brought on board, right? You don't really need everything. Instead, I want to very easy to put something dynamically on the front end without services, without data modeling, without any of that. What's the easiest way that I can put something on the screen that is dynamic, right? And React addressed that issue, leaving some of the other architectural issues. You choose. You could choose Knockout, or you could choose some Backbone and some other library to deal with those other issues. And Vue is somewhat in between those two. And so we'll focus on those two: 2010 Angular, the new version of Angular, and the latest version of React. Okay, but there's plenty of others. Ember, also Sales, Meteor. These are all really cool competing frameworks, but these three, Angular, React, and Vue, I would believe is the ones that are most common today, right? Are most valuable today. Here's somewhat the architecture where all of these pieces, where they execute. We have the client, we mean a browser, right? In this case, the browser is a type of client that uses HTTP to send requests to the server. And you have browsers, desktops, games, other servers. You have technologies as HTML, CSS, all running on the browser. And then on the server, you have all sorts of servers: JBoss, Tomcat, Node, FTP servers. We're going to be focusing on Tomcat and Node in this course, and the technologies that are going to be running on the server are Java and what? And JavaScript. What? Why isn't this listed here? JavaScript, but on the server. And the servers will allow us to access other resources, such as all sorts of static content, as well as dynamic data that's stored in databases, and relational databases and non-relational databases like Mongo. Okay. Now there has been an evolution on how content is rendered, right? Early on in the 2000s, late 90s, early 2000s. Typically content was dynamically rendered on the server side. So technologies such as a PHP, Python, JSPs or ASPs, these are all server-side rendering technologies, right? You make a request, the browser makes a request to one of these dynamic content frameworks such as ASP, PHP, JSP, Python, etc., right? And the server accesses the database or makes an HTTP request elsewhere, and then dynamically builds a page, okay, with if statements and loops and whatnot, right? And it dynamically computes what the HTML that it's going to come back with, right? And then it spits out, for a static HTML. The browser sees just static HTML. The server generates it dynamically, but the browser sees it as just plain old HTML. It doesn't even know that it was dynamically generated, that a loop iterated over some array to generate a long table. It doesn't know. It only sees the static table, right? But it was generated dynamically on the server, so it's calculated on the server. So we have abandoned this model. It's still there. It's still useful, still with us, but more and more we see a an evolution towards this new model. In this new model, there's a request first for a static template plus JavaScript that is downloaded from the server, and once it downloads from the server, the server doesn't do any computation, right? It just returns static HTML and static JavaScript, right? So as far as the server is concerned, is always returning with static content, right? But when it reaches the browser executes the JavaScript and it updates the template, right? So that typically there's two types of requests from the browser. The first request is for the template and the JavaScript, and typically there's a second request asking the server for data, right? Because the browser doesn't have that array, the server has the array, right? Because it's in the database. So the server needs to query the database, retrieve some records, and return some array. Right? So typically this model needs two requests. The first request for the template and the JavaScript, and the second request for data. Okay? With the data, the browser can then execute the JavaScript and then dynamically use JavaScript to render the table, right, on the browser. Right? So it dynamically renders the table on the browser as opposed to having been rendered on the server. So this is the new model, which is most common today. Right? The example that I always use that for me was most evident was when for years I had been using MapQuest. I don't know, anybody remember MapQuest? So MapQuest provided identical use cases that Google Maps eventually provided, right? It allowed you to zoom in a map, search for an address, be able to pan right, pan left, north, south, right? But it was all using this model. Using this model, right? The map, the user interface was rendered on the server, and it gave the user experience of, I click, right? I wait, right? The whole page is dropped, and then it re-renders entirely, right? With a brand new page with a map maybe slightly, animated to the right or to the left. Yes, and this was the model for every application, right? Up to that point. Google introduced this new idea, Google Maps. Right? I don't know if anybody remember the first time of using Google Maps. Well, I guess if you haven't used MapQuest, you don't know what you're missing. So the first time I used Google Maps, right? I guess I'm old enough to see the difference between these two. Of being able to just grab the map, right, and just drag it from left to right and just flick it. And just animated, as all these images were being dynamically loaded from the server, right, when being added to the DOM in a quick fashion, right. This was a completely different user experience, right. There was no jarring, unloading of the page and re-rendering the entire page. So most of the page was static. There was only a small portion that was being dynamically fed from the server. A complete different experience, right? And that's where most of the applications are going today, right? So your Facebooks, your Twitters, of the world, these are all using this brand new way of implementing applications, right? Or a mixture of the two. Okay. Usually what they'll do is that they'll use this model for a first rendering of the page. Right, they'll compute the page on the server first, right, and they'll shoot it at you very fast, right. So the landing pages typically use this model, right, because typically they're very heavily computation heavy, right, especially if it's like Amazon, where it has to fetch your history, it has to offer you all this stuff based on your records and so it has to calculate a lot of dynamic stuff, right? And so it would be very expensive to give you an empty template and then have a second query of fetching all this data and then dynamically rendering it, right? It would be jarring in that you would have all these spinning, waiting for the data to come so you can dynamically render it. Right, so typically they use a combination of the two, especially first landing page, very quickly shoot something at you when we're very finicky. If a page takes more than half a second, we're gone, right? So if we can render something in front of you very quick, and then keep you there, right, and then dynamically update as you go, is a better experience. Anyway, web application development follows the same best practices and engineering skills that you find in other engineering fields. Source control, naming conventions, planification, communication. So a lot of best practices of designing and whatnot, and uses a lot of the same architectures that we've come to be mature and love, borrowed from other frameworks, such as the model view controller. This is something that became very, very popular in the early 2000s, and now it's pervasive everywhere. Right? Most frameworks use some form of this design pattern of breaking up large applications into three buckets, right? That have different concerns. Right? There's the concern of how am I going to render this. Another concern is how am I going to structure the data, right? And the other concern is how am I going to handle user events, right? As they type and move the mouse and fill out forms, right? Those are three big, huge concerns, right? How am I going to render this? How am I going to handle user events, right? And how I'm going to describe the data structure, right? And MVC, right, handles those, addresses those three as separate concerns. And Angular, for instance, makes it very explicit that you code following that model. Right? You have the HTML to deal with the view, you have the components to deal with the control, right? You have your services to deal with your data, right? And so these frameworks, right, make it explicit that these are three different buckets of concern, and then they have to be dealt in different ways, right? This is straight from from things that have been around for decades, right, and that now have made their way into clients. Many other design patterns that we'll be using in version of control has been around in Java for quite a bit, and now it's also available in JavaScript. Right? Angular uses quite a bit of inversion of control. Services, factories, singletons, all sorts of very cool design patterns that have become mature on the server side, but now have made their way into the client.